Apart from error control and flow control, one of the major responsibility of the data link layer is framing. Framing means that suppose you are sending some frames from one host to another host. Let's suppose this is A, this is B, and you are sending some of the frames. Now, when you are sending using this transmission medium, suppose the frames are like followed by one another, which means this is frame number one. Let me just call it F1. This is frame number two. Now, when B receives the frame 1, like let's suppose frame 1 is this and frame 2 is this, and when B receives the frame 1 and frame 2, then B should be able to identify that this part of the portion is frame 1 and then frame 2 is starting, right? Because we will be sending some bits followed, bits like 1 0 1 1 1, something like that, right? So we will be sending a stream of bits, and now it's the job of B to identify that how like what is the structure of frame 1 and how the structure is of the frame 2. So A should be doing something in the frames, and that is what called framing, that so that the B can identify that this is the start of the frame 1 and this is the end of the frame 1. Similarly, this is the start of the frame 2 and this is the end of frame 2. Because if we are sending some stream of bits, then it is hard for B to identify if A does not do framing. So that's where framing comes in the picture. So this is our IP datagram, that's what we are getting from the network layer, and then we do what, we append this IP datagram with the data link layer header, and this there is something called trailer. So here we have CRC check generally, which means like if there is any error, so using the CRC, receiver can easily able to identify whether there is any error in the data or not. So trailer is like nothing but a CRC in most of the cases. We will be focusing on the header. So header is something basically that tells us of the start of the frame. So like there are different ways to do framing, and one of the ways is called the fixed length framing, and another way is called variable length framing. So fixed length framing means that every frame is of the fixed length, which means let's suppose I say that every frame is of 2000 bytes, something like that. Then in this case, like B can easily identify what is the end of frame 1, because once it receives some bits, it will just count 2000 bytes, and once the 2000 bytes are over, it will say that it is a frame 1. Now the frame 2 is starting. So in the fixed length, there is like no explicitly no need of like framing, which means like we do not need to have something special to do framing. So that is very easy, but that is not being used, because suppose you do not have 2000 bytes to send, then you will do unnecessarily padding. So that is why that is absolute and nobody is using this fixed length framing. Now another is called variable length framing, and here also we have two parts. One is called using length field. I can tell that okay, this is the length of this frame 1, so just use next 1000 or next 2000 bytes as a frame 1. This is one of the way. Another way is called using flags. So both of the methods are like equally popular. Length is being used in Ethernet frame, and flags are being used in there are protocols at the data link layer. One of the protocol is Ethernet protocol, another protocols are like PPP protocol and HDLC protocol. So these protocols are using this flag method, and Ethernet is using length method, right? And there are many protocols like token rings and all, these are also using the flag method, but that's not in the syllabus, so I will not talk about them. Even like the more details about the Ethernet, PPP and HDLC are not in the syllabus, but we will just look at the these headers, that how they look. So in variable length framing, what we do, we somehow tells to the B, to the receiver, that either this is the length of the frame, like this is one of the way to tell about the start and end of the frame by conveying the length, and another way is to tell that what I will be doing, I will be appending something called as flag as a start of the frame, and after the frame ends also I will append the flag. So I will append two flags, and the whole frame, this whole frame will sit between these flags. So I will be appending at the start and the end, there will be two flags I will be appending, and this whole frame will be in between these flags. So this is another method. What is the benefit of this method? Like what we will be doing, we will be like when B receives, so we will be checking that B means receiver will be checking that okay, now frame has been started, and now after it finds the another flag, it will say that okay, now frame has been end. So B can easily identify start and end of the frame. So this is another method. Now let's talk about this flag method and what are the different ways to append the flag and how these flags look like. One of the ways called byte stuffing and another way is called bit stuffing. So again, there are two ways to implement this flag method. See, this variable length size of frame, variable length frames, framing can be implemented using two ways. One is using length, another is using flags. Now we can implement these flags using two ways. One is called bit stuffing, another one is called byte stuffing. Now let's look at byte stuffing first and how byte stuffing works, and then we will move to bit stuffing. So in byte stuffing, what we do, let's suppose we have some data. This is the data that I want to send. Then I will be doing what? I will be appending some flags to the data. This is a flag, this is another flag. This will tell the start of the data, this will tell the end of the data. And then this is at the center side, and receiver can easily identify the start and end of the frame using these flags. This is okay, but here is one problem. The problem is that what if this data itself contains the flag, right? So suppose that my data itself is like this. Let's suppose this is my data and this itself is containing the flag. And anyway, I will be appending. So flag is nothing but some stream of bits, stream of 1 and zeros. So let's suppose this is my flag. Anything could be flag. So this is my flag 101001. This is my flag, and then this 101001 will be here. So generally it's 8 bits or 1 byte. 1 2 3 4 5 6 7 8. Let's take it 8 bits. So this is my flag, and this flag is also present here. 10101010, right? And then 10101010. So I have appended these flags to the data, but here data itself is containing a flag. Now what will receiver do? This is at the center side. Now what will receiver do? After receiving it, receiver will think that my data is between two flags. So one flag it will find at the start. Let's say this is the start, or maybe this is the start, doesn't matter. So one flag it will find at the start, and another flag it will find within the data only. But receiver doesn't know that this flag is within the data, which means receiver will think the data is between these two flags only, and by mistake receiver will take this as a data, right? Now for that there are two solutions. One is bit stuffing, another is byte stuffing. Now currently we are discussing about the byte stuffing. So in this case what we do, we, like, you got the problem, right? So the problem is that receiver will by mistake think that this is the data. Otherwise the whole data is actually this much, but receiver will think that this is my data. So to avoid this problem, what we do, we stuff some of the bits or some of the bytes in the byte stuffing. So what we do, we say that whenever there is a flag in the data, then we will add some escaping characters. So let me add one character, maybe a null character or some character that we can decide, like the protocol can decide, and the sender and receiver both knows about this character. Let me just call in the abstract sense. Let's suppose I am adding one character which is of 8 bits. Let's suppose ESC, okay, which is a escape character. So what it will be doing, now whenever I find a flag, see here, whenever I find a flag in the data, suppose this is the data and I have a flag. So before flag it will append the ESC character which is of 8 bits. Now what is the benefit of it? When it gets delivered to the receiver, this is my receiver, whenever it gets delivered to the receiver, then receiver will say that okay, like whenever like receiver finds the ESC flag, receiver will say okay, let me just remove this. So this is called de-stuffing. So receiver will de-stuff it and receiver will remove this ESC flag, and it will not treat this flag as an end delimiter, which means let's suppose this may start this flag to this flag. Let's suppose this is the start, this is the end. So whenever I'm appending ESC, it means that it means of two things. One is that receiver will ignore this ESC flag. Another thing is that receiver will not treat this flag as a end delimiter, which means receiver will not stop here, receiver will keep on reading till the next flag. So this will successfully parse it, which means receiver will successfully get the data between these two flags using this ESC character. I hope you got it. So like this could be anything. Let's suppose my ESC is generally, let's suppose it's a null character, which means I will add just a null character with before the flag, and flag could be anything. Let's suppose it's a dollar character. So what I'm doing, I'm appending dollar here, but if there is a dollar in the data, then I'm appending /0 or \0 in the data, so that whenever it goes to receiver, receiver will see the ESC flag, receiver will ignore the ESC flag and also not treat this dollar as a end delimiter. I hope you got it. But there is a problem. What if your data is having ESC and flag? So see, one thing is that data is having dollar, or let me just say flag or dollar, anything. So which means you will, if you pack your data between these two dollars, but data itself is having dollar, then the solution is that you will append \0 or some ESC character to dollar or the flag. Then what will happen, that this data will not get sent like this data will get sent like this. So this is dollar, and here you have ESC character and then flag. So this data will get sent like this, and then at the receiver side, this is at the sender side. At the receiver side, receiver will ignore this, and then receiver will will not treat this as an end delimiter, and things will work perfectly. Now what if, second thing is that if data itself is containing ESC and dollar, which means in the data itself you have something like this. So you will pack the data between the dollars, that is okay, but in the data itself you have something like this, which means in the data itself you have this is the original data before stuffing. This is original data. See, earlier the original data was this only, which means earlier original data was just having dollar, and after stuffing this becomes this. So after stuffing, right? Now original data itself is having this. Now if you send this original data as it is, then what will happen? The receiver will think that this ESC character has been added by you, so it will remove it, and receiver will only read this dollar as a data. It will not read \0 as a ESC as a data, right? Which is a part of data. So in that case, what should we do? Like we cannot send this as it is. So what is the solution? The solution is that, like you can think about the solution. The solution is that we will add two ESC flag here, one for this ESC, one for this ESC, which means after stuffing it will become something like this. \0, this is what we have added for this ESC, and then \0, this is what we have added for this dollar. And my originally I have packed this in between dollar and dollar, which means for this ESC I have added another ESC, for this dollar or this flag I have added another ESC. So this is after stuffing. Now whenever it reaches to the receiver, receiver will always ignore the ESC, first ESC, ignore this first ESC, then take this as a part of data, ignore the second ESC, it will take this as a part of data. So at the receiver side, the rule is always ignore this and take next character or next byte as part of data. So this is the rule at the receiver side. So receiver will ignore this, will take this as a part of data, will ignore this, will take this as a part of data, which is in fact we wanted, right? Because our data has \0 and $. Now what if your data has only \0, which means you have packed this between $, and your data has only \0. Now what it will do, if the rule is this, that it ignores this \0, it ignores this \0, and it will treat the next character as a part of data. So if you send this as it is, now receiver has this rule, right? It will ignore this, but you do not want it to be ignored. Now what is the solution? The solution is that we will add another ESC for this \0. So this is my original \0 and I will add another \0, which means at the receiver side what it will do, it will just read it, which means it will ignore the first ESC and will take this as a part of data, which is in fact we wanted, right? So rules are very simple. Whenever you have ESC or flag, add another ESC. That's the only rule at the center side. This is the rule at the center side. And at the receiver side, I have, like, whenever we see ESC, so whenever receiver sees ESC, then ignore it and take next character or byte, because character is just one byte, so either I write character or byte, doesn't matter. So let me just say next character as part of data, right? This is the rule at receiver side. So see here, suppose that in the original bytes you have just flag, so you will be appending with ESC. If you have just ESC, also ESC. If you have ESC and flag, then this for this ESC one ESC, for this flag one ESC, right? Like this. If you have ESC ESC, then for this ESC one ESC, for this ESC one ESC. So always append ESC for each ESC or flag. I hope you got it. So these are the original bytes, and this is the bytes after the stuffing. This is called byte stuffing or character stuffing. Or character stuffing. But here you can see clearly a disadvantage, which is that if you have multiple ESCs or flag in your data, then unnecessarily you are stuffing too much and your data size will be too much, right? Which is not desired, because you are sending unnecessarily many bits, which are anyway like receiver is anyway going to remove them. So that's why we have another solution, which is called bit stuffing. It says that if your data matches with the flag, if data contains flag, then only stuff one bit. Which means what? Suppose that you have some bit pattern here, which is of your flag, and then you have the data, and then you have another bit pattern for the flag. Then what you need to do? If this data is containing the flag, then just append or just stuff one bit. Now generally in this case we take flag, in the bit stuffing case we take flag as 0 and then 6 ones, 1 2 3 4 5 6, so these are the 6 ones and then 0. So this is the flag generally almost all the protocols uses. So in the bit stuffing, these are the flags that most of the protocol uses, which are using bit stuffing. So one example is HDLC. HDLC is one of the protocol at data link layer which uses bit stuffing, right? So anyway, now like this is the flag, and here also you have the same flag, which means 0, then 6 ones, 1 2 3 4 5 6 and then 0. So clearly this is of 8 bits or 1 byte flag. Now suppose data also has this pattern, which means in the data also you have 0 1 1 1 1 1 1 0. Data also has this pattern. Then what you can do? You can just stuff one bit. Let me just stuff one bit. Maybe you can just say that if data also has the same pattern, then to break this pattern you can just append or just insert or just stuff one bit, which is 0 here. in between the flag. Now what it will do, at the sender side you are appending 0 after 3 ones, right? So at the receiver side what we can do, whenever we see 3 ones and then 0, just remove the 0, right? This will work perfectly. But generally we append the 0 not at the after 3 ones, we append the 0 after 5 ones. The reason being is that, like, these are the 3 4 5 6 0 and then 6 ones and then 0. If we append 0 here, or we append 0 here, like after 5 ones, which means here, then the difference is that after, like, a probability of occurring these 3 ones is quite common rather than probability of occurring these 5 ones. That's why, like you will get to know it in just a few minutes, but be here currently. So that's why we add 0 after 5 ones only. Okay, which means if you have like some pattern like this and you have choice with like either to append 0 here or here or here, then we always go for maximum number of ones. And here the maximum number of ones could be 5 ones, because after 6 ones anyway there is a 0. So if you append 0 here, so it will be just a flag, it is not breaking the pattern. So you need to append a 0 in the flag such that the pattern is broken, and the probability of occurring these ones should be very less, which means you should be appending 0 after 5 ones only. I mean, most of the protocol does this. Otherwise there is no such fixed rule, but most of the protocol append 0 after 5 ones only. So let me just give you an example what's going to happen. Suppose your data contains, this is your flag 1 2 3 4 5 6 0, and your data also contains this as a bit stream 1 0 1 1 1 1 1 1 1 and then 0, and here also you have the flag which is this, right? Now at the sender side you will do what? You will append 1 0 here, or you will stuff 1 0 here, and at the receiver side it will clearly remove this 0. That is okay. I hope you got it. At the receiver side it will remove the 0 after 5 ones. But what if we have this as a data 1 2 3 4 5, and then already we have the 0 in the data, this as a data in data. Then if we send it as it is, which means we append this flag at the start and then data which is containing this 0 1 2 3 4 5 0 1 0 and then flag. Suppose if we send it as it is, then receiver will think what? This 0 has been added by us as a sender. Then receiver will remove this 0 and will not consider this 0 as a part of data, which is wrong, which is clearly wrong. So what should we do? See, our initial idea was that we can stuff 0 after the 5 ones, and receiver will anyway remove this 0 after the 5 ones, and receiver will not consider this 0 as a part of data because anyway we have stuffed it. But what if this is a pattern in our data? Then what will receiver do? I mean, receiver doesn't know whether this 0 is a part of data or we have added, so receiver will anyway remove it. Then what is the solution here? We will append 0 here also, which means whenever there are 0 followed by 5 ones, then always we append a 0, irrespective whether we have the flag or we do not have the flag. See, this is not matching with my flag, but if I send it as it is, then receiver will remove this 0. That is why I will stuff it, which means I will, after 5 ones 3 4 5 ones, I will anyway append the 0 and then this 0 1 0. This is 0 1 0, this is 0 triple 5, this is 0 1 0, this is what I have stuffed, right? So at the receiver side the rule is that whenever it sees 0 followed by 5 ones, I will, the receiver will always remove this 0, right? And then it will consider remaining part as a part of data. So at the sender side the rule is that after 0 1 2 3 4 5, after this pattern always append 0, right? At the receiver side the rule is that after 0 1 1 1 1 1 always remove 0, right? This is the rule at the receiver side and this is the rule at the sender side. Now suppose your data is this only, which means your data is 0 1 1 1, I mean 5 ones, and it is basically not containing flag means 0 5 ones or 6 ones and then 0, and then 0 1 2 3 4 5 6 and then 0, and your data is this. So your data is not containing the flag, which means your data is 0 followed by 5 ones, and maybe it is having then 0 0 something like that. Your data is not basically containing the flag. Then will this rule will always be applicable, which means should I always append 0 after the 5 ones? See, if I send this data as it is, then at the receiver side the rule is that it always removes 0 after the 5 ones. So it is going to remove this 0 if I send this as it is, which is wrong, right? Because this 0 is a part of data. So we will follow these two rules always, which means even though this is not matching with my flag, then also I will append a 0 here, which means I will stuff a 0 here, so that receiver will remove this 0 and will consider everything as a part of data, right? So it does not matter whether your data is having flag or not. At the sender side, this is always the rule that we are following. At the receiver side, this is the always rule. This is the rule that we are always following, right? So this is the flag that we generally use in the bit stuffing. Otherwise, it is not fixed. I mean, it depends on the protocol. It depends on the question. So in bit stuffing, the rule is that the process of adding one extra 0 whenever the 5 consecutive ones follows a 0 in the data, so that the receiver does not mistake the pattern 0 then 6 ones and then 0 for a flag, right? So whenever this 0 6 ones zeros comes within the data, then like always anyway like we are appending 0 here. So if this comes in the data, then anyway we are breaking the pattern and then we are appending the 0. So at the sender side, this is the rule, which means we always append 0 after 5 ones, 0 5 ones, right? Here if you see here, then here we do not have flag in the data. Why? In this data we do not have 0 6 ones and then 0. We do not have this pattern. If you count number of ones, I think these are 7 ones. So we do not have it, but it does not matter. After 5 ones, anyway we are going to append 0. See here, after 5 ones, 0 0 followed by 5 ones, we are anyway going to append 0. And this is what is the frame that we are sending, and then this frame will get received by the receiver, and then receiver will unstuff it, which means it will remove the 0 after 0 followed by 5 ones. Okay. So there are two type of framing method that we have seen. One is bit stuffing, another one is byte stuffing. But the methods are not limited to this, and there are some other methods also. So there are some methods which uses the support of the physical layer. So there is some signal that can never appear in the data. So in 0 means the low signal and 1 means the high signal, but there is some signal that I am not also aware of, to be very frank, but we are not concerned about it because it is not related to computer science. I mean, details are not related to computer science, but yeah, there is some signal that can never be a part of the data. So we use those signals as a flag, and this is with the help of physical layer. So some of the protocols uses this kind of thing, and as I told you, some of the protocols, one of them is Ethernet and another one is Wi-Fi protocol, which is 802.11. So these protocols uses length field, right? So this protocol does not uses your bit stuffing or byte stuffing. This protocol uses the length field. Now if you remember, we have divided the data link layer into two parts. One is your normal like link layer control, LLC, or this is also called a data link control sublayer, and another one is used to access the media if there are broadcast domain. Now in case of broadcast domain, I do have some protocols which we have we have discussed. One of them was CSMA CD. Now CSMA CD used to decide like how we are going to access this, and above CSMA CD we use like here in the data link control sublayer, here we use something called as Ethernet as a protocol, right? And here if it is a point to point, then we use HDLC as a protocol or PPP as a protocol. Now this HDLC or PPP uses bit stuff, like HDLC uses bit stuffing, PPP uses byte stuffing, and Ethernet uses the length field. So in the broadcast domain, like we use Ethernet. In the point-to-point networks, we use HDLC or PPP as a protocol. So this is a frame of PPP, and this PPP frame, like we are not going into the detail. In this flags, they uses something called as, like that we have just discussed, that is byte stuffing. They uses bit stuffing in the HDLC frame, and this Ethernet frame is using the length field. If you see a type or length field, so basically, like there are two type of Ethernet frames. One is using the type field, another one is using the length field. Now, like currently, most of the networks uses the length field. So if we are using length field, then we can easily identify start and end of the frame, because we know what is the length of the frame. If you are using type field, then there are some other methods called interframe gap or something that are used to identify start and end of the frame. So for that we do not need to worry about it, because that is not that is not in the scope of gate, so let's not worry about it. But yes, this Ethernet frame uses, most of the time it uses the length field, and using which we can determine the length of the whole frame. So, and this these protocols are using bit and byte stuffing. Thank you.